Hey folks, Ben Gilbert here with Palmer Luckey, founder of Oculus VR and the makers of the Oculus Rift. And you guys have a new prototype here at CES 2014, right? The Crystal Cove prototype?
Yeah, so we have a prototype that's been codenamed Crystal Cove internally, and it has two really big new features. The first is adding full 6-degree of freedom tracking. So previously we were able to track orientation in space. You could track where you were looking, but it wasn't possible to tell if it was your head moving or your body moving. So as long as you kept your body still, you could look around and it would always be pretty accurate.
Sure,
but if you wanted to tilt or if you wanted to lean towards something to get a better look at it, we weren't able to reflect that accurately.
And before we move on to the other features, I want to make sure we stress how huge this is, right? So when you're playing something like Eve Valkyrie and you're in the cockpit and you're looking around and you move your head forward and you don't feel like you move forward, there's a disconnect there. But now, with the updated, there's an update to the game, and there's the update in the Crystal Cove prototype, so you actually can lean in and you can look at your modules, you can read different pieces of essentially HUD, right, that are inside the cockpit.
Exactly, and there's a lot of other game mechanics that it allows. Like if you want to lean around a corner, or if you want to, Matrix style, dodge the bullets, you could do that. So I think we're going to see a lot of cool games taking use of it, and it's really cool. We've been playing around with it internally for a few months now, working on the position tracking system for about a year, and it's finally coming together. It's pretty exciting.
It's something that I always harp on when I talk to you guys, right? Like I love the promise, and the original Rift, the headset that even had the duct tape, I think you put that on and you get it, but then you start wanting more, right? You immediately say, like, I see all the promise in this, now I want to move forward and have it feel that, and I want to be able to move my hand and see that, right?
And everybody knows what they want. That's one of the cool things about VR. Sure. It's not a technology where you have to show it to people and convince people that it's actually worthwhile. Everyone's seen the Matrix. Everyone's seen, VR's been pervasive in media for the past few decades. So everyone's seen something and said, I get it. So if VR is around, you can do these incredible, fantastic things without actually being in danger, the things you would never be able to do in real life. And so we're continually trying to get there. And the other nice thing is some products, they have to kind of figure out their roadmap of where they want to go feature-wise. Like, what can we innovate? What feature can we invent that'll be better than what it is right now? And that's difficult for some products.
Sure.
For us, we have a benchmark. We need to get as good as real life.
Right.
And that's a long way away. We're nowhere close to it. But every bit along the way, we're getting closer to that goal.
So that's actually interesting you bring that up. So I was speaking with Brendan Arribe, CEO of Oculus, the other day, and he was saying exactly that. Essentially, the closer you can get to reality, the better it is for people's perception of that, for killing stuff like sickness, for motion sickness issues, and those kind of things. And that's really fascinating to me, right? This concept of bringing it as close to reality as possible, and that way more immersive experience you get with something like an Oculus headset or VR in general.
Well, we are very sensitive to how we perceive reality. Like, one of the reasons that you feel sick when there's any kind of mismatch is because it's your brain saying, over the years, my brain's evolved so that if I'm poisoned and my perceptual system is screwed up by it, it's just you need to throw that up and get that out of your system right away.
Right.
And we still unfortunately have those instincts. So you have to get to a certain threshold to even make virtual reality usable. And it's never been at that threshold, certainly not on a consumer level for a long time. And as you continue adding more and more things, like you said, hand tracking, body tracking, full haptics, you're going to get a much more immersive experience than really it's primitive what we have today. This is the early days. These are the monochrome monitors of VR.
Which is insane because it's already so impressive, right? You get it on, and my mom or people who don't play games, right? They put it on and they get it immediately. Like you said, you put it on and you understand. It's intuitive. It's like Wii Sports. You just see it and it makes sense. There's no explaining necessary.
Well, that's absolutely true. So we spend our whole lives learning how to look around. Like, instinctively, if I hear a sound over here, I'll turn my head and I know exactly where to turn it. I know how to examine objects. We also understand, basic concepts like how to reach out and touch something, or how to pick it up, how to even, aim a weapon. When you compare that to these, right now we're using keyboards and mice and gamepads, and especially if you show them to people who aren't tech savvy, you say, yeah, just manipulate the virtual environment using these multiple rotating discs and buttons, and you can just pick anything up and look around and do it, whatever. And the example I like, have you ever seen like older people with no game experience? They'll try to play a first-person shooter with a mouse, and they'll end up just spinning in circles, looking at either
the ceiling, right?
Yeah, the ceiling or the ground. And it's because that's a very hard interface to learn. It's
Absolutely.
It's a good interface. It's a superhuman interface that lets you move faster than you can in real life, but it's not a natural interface.
Right.
So when you put people in VR, even people who haven't played games, they're instantly able to look around inside of a game, and they're like, oh, I get this. I can look around. And if you have motion controllers, you know, it's one thing to have a motion controller that's controlling an abstraction of yourself out on a screen. That there's a disconnect there. When you have a motion controller that is perfectly one-to-one, you know, at the right scale, at the right size, you can reach out, pick up something, and hold it. Anybody can do that. They're leveraging their entire lives and thousands of years of, you know, of
human existence.
Of human existence that's all been, you know, around these kinds of interactions. We've only been using gamepads for, you know, a couple decades.
Right, right. And so to get back to the Crystal Cove prototype.
Oh yeah.
Yeah. No, this is all my fault. So to get back to that, there's a couple other additions, right? And another major addition is the kind of, I believe it's called low persistence.
Low persistence.
Right.
So it's kind of a difficult technology to explain, but the idea behind it is that with low persistence, you can entirely or almost entirely eliminate motion blur from the display. And a lot of people think that motion blur is dependent on, you know, how fast the panel can switch. It turns out that the way that our brain perceives displays, it's very different from how our eyes see the world is a lot different from what we show on displays. And it starts to break down when you use it for virtual reality.
Sure.
I'll try to keep it short. on a normal display, a full persistence display, what you generally do is you render an image, send it to the screen, it displays the image on the screen, and then it holds that image for an entire frame.
Okay.
And then the next frame comes, then it starts over again, and it holds it on the screen. The problem with that is that that rendered image, it was only right when you sent it to the display. The rest of that is an old image that's just still on the screen.
Okay.
It's kind of like a broken clock. A broken clock is right for a very brief period every once in a while as the hands go around, but most of the time it's actually just garbage data.
Right.
And so what we're doing with our new prototypes is we're using OLED displays that can, first of all, switch very, very quickly so to minimize latency.
Sure.
And how it works is you render the frame, send it to the screen, it displays it for a fraction of the frame, then turns the display off, and then it's black until it gets a new image. Then it flashes that image, black, flashes a new image. And if you do that fast enough, you end up perceiving a continuous image that has no motion blur whatsoever. So that helps with, you know, sim sickness, and it also makes everything in the world feel very grounded. Before, even with the low resolution, you know, there to kind of cover it up, if you turn your head, the world would seem to shift a little bit because it would actually be smearing across your retina for however long the image was persisting. With the new Crystal Cove prototype, you turn your head and there's no motion blur at all, and it's actually probably the biggest advantage. Like positional tracking, it is a big thing, but we were always going to need it. It's been something in the works.
Expected.
It was expected, and I think any VR system is going to need that for sure, just to, you know, have basic compatibility with the kinds of games that are going to come out. But low persistence is really the key thing that we didn't really expect to. We had no idea about low persistence really when we first started developing the Rift, and we've been trying a lot of things to eliminate motion blur, and it ended up working. The only way you could possibly get around needing low persistence would be to have a frame rate so high that each whole frame was as short as that pulse. So you'd need to be well over 1,000 frames a second. So we're a long way from rendering 1,000 frames a second and, you know, having a display to go that fast. So for the meanwhile, this was pretty great.
And so another part beyond the motion blur cutting down, which in fairness, that's huge, right? Like, so when I was playing Eve Valkyrie and I turned my head and it blurs the thruster sign or whatever the various HUD elements that are on before you launch out into space. And then it was flipped on by Aaron Davies, I believe, the developer relations gentleman from Oculus. And you turn your head, and it's like real life, right? It's like when I can see Central Hall off in the distance, a sign.
And even no matter how much you move, you can see it.
Right. Yeah. And that's huge, right? Like that makes a huge difference in, again, bringing it closer to reality. Bringing it one step closer to what you're expected.
And it's not just like about legibility, like scrolling on a web page. Actually, low persistence is awesome for scrolling web pages because the text it's like moving a sheet of paper rather than, it doesn't blur when it moves.
Right, right. Sure.
So that's cool, but it's not just for text or detail. Even basic things like, you know, this featureless, boring white table. It remains perfectly fixed in space. That makes a huge difference in how grounded you feel when you move, and all of the edges on it remain perfectly clear.
Right. So also, you mentioned it a little bit in the when we were talking about the low interference, but the OLED screen is another major addition, and that looks great, right? It just, I think the difference between the Rift prototype I have at home that's relatively low res, and it doesn't have the motion tracking and stuff. And the newer one, the Crystal Grove prototype, it seems like a giant step forward, right? And between all these different things that you guys have introduced, it makes that step where it's closer to reality way closer, right? And it really makes it way more convincing.
It definitely does. Yeah. And what's cool, the prototype we're showing, we're going to be going beyond that for the Consumer Rift as well.
Sure.
But, we wanted to show off the progress we've made because it really is something that's convincing. It's a lot of people who have reservations about it, seeing the older developer kits. I mean, those things were designed more than a year ago. I mean, actually way more than a year ago.
Right.
And we only got them to market, earlier this year. We've made it so much progress since then, so we wanted to kind of show that off.
And the other part that I believe this might not actually end up in the consumer model is there's a camera now that's tracking, and that's making it so that there is depth tracking available. And that's something that might not end up in the final product, I believe.
Right now, it's the front runner. I mean, we've been working on a lot of different tracking systems: optical, magnetic, ultrasonic, mechanical, all over the place. And right now, optical tracking has definitely been the best option. And we're not just using that for tracking. We're also using our existing inertial system with a gyroscope, magnetometer, accelerometer. And so we're combining the data from these two systems. So they complement each other very well. They have complementary strengths and weaknesses. And so that's the front runner solution right now.
Okay, and you said that this will not be, these things that are in the Crystal Grove prototype aren't the only things that are going to be in the final consumer product. What are the other kind of major speed bumps you want to get over before getting to that final product?
We've got a few tricks up our sleeve.
I understand you might not be able to say everything also.
There's a lot of things we can do. One thing that's related actually to the display that we're using. One nice thing about using an OLED display and a head-mounted display is, even when in television, OLEDs, they do give really good blacks, don't get me wrong,
sure.
But these contrast ratios you see listed, they're the hypothetical contrast ratios in a perfectly pitch black room. If you're talking about a real-world situation, TVs are in at least somewhat lit rooms, so even then the blacks can't be at all that black.
Sure.
They can be black relative to everything else, but it's very hard to get to true black. Because we have a head-mounted display, in this enclosed system where your eyes are blocked off from the outside world, we can actually do really, really true blacks, and we can calibrate each of the displays to provide a standard color curve for all developers. So, you see it play a lot of games, and they have you adjusting the gamma until and then the brightness until you can see it on your display. That's because they don't know what your display looks like.
Right.
But a lot of people have terrible displays, and they're terrible in different ways. And so you have to have that ambiguity about what your game's going to look like. Because we're going to provide a standardized experience, developers that say, this is how it looks on my Rift here in my development studio, they know that anyone playing that on a Rift, it's going to look exactly the same.
So when do developers get their hands on this stuff, right? Like you said, the Crystal Grove prototype is here to showcase the advances you guys have made since the dev kit shipped, but at the same time, this isn't necessarily a new dev kit, right? This is just a prototype. So when do developers get their hands on this stuff? And how do they develop for it without that,
So we're not announcing anything. Well, so I think there's two questions.
There are, yeah.
We're not announcing anything yet, but what we've said in the past, at some point we are going to ship another developer kit that has features that are very similar to the consumer version.
Right.
Because you need to be able to add these things like positional tracking, factor in low persistence into your UI. You need to be able to get all those things working so that it's not a big effort to get it working on the consumer version later. As far as the development path, how can you work without the development kit? The way our SDK works is there are exceptions that we're trying to fix, but generally it's forwards and backwards compatible. So if you develop a game with the current Rift, we're feeding back in not just orientation, but we have a head model for moving your head when you tilt it.
Okay.
So if you have your software working with that, when you get a new dev kit, you should be able to just plug it in and your same software works, except now it's getting true positional data instead of what's faked by our SDK off what it can infer from your body's position.
That's fascinating.
It's like in the office, all the games that we did a game jam recently, and we were able to play all the games using our latest HD prototypes. So, anything that people are making, even with this older hardware, it does work with newer hardware. So you can start developing right now, and no, you won't get low persistence or positional tracking, but it's not a crippling thing.
No, I'm sure that the developers out there are very happy to hear this kind of stuff. So I kind of wanted to talk to you about you. I think we've heard a lot about the Rift, but you're an interesting character yourself, right? You're really young for the industry, and you're at the head of a company that has got a ton of hype behind it. So what's that like? Where did you come from? What's your background? I mean, there's a few questions in there, but
So I'll answer the what is it like one, and then we'll come back to the other one.
Sure.
I'll tell you the life story. It's kind of a weird transition because for years I've worked on stuff in my garage as a hobbyist, and ignoring all the things like I can get companies to answer my emails now, and people are willing to email me back about things. I started out working in a garage, working on all kinds of technologies, and then after we launched our Kickstarter and launched the company, there were only a few people at the beginning, so everyone was doing everything. I mean, we were all doing the marketing, the traveling, the engineering, the customer support emailing, and so my duties just vastly expanded out to be everything, because everyone was doing everything. And then as the company is growing more and getting more specialized people, like specialized optical engineers, sensor fusion engineers, software developers, I've kind of been able to slip back into the role of developing hardware and making new VR stuff, and that's been really good.
Okay, so before we move back into the life story aspect, then what is your day-to-day like now, as opposed to, I mean, just a year ago you guys were, I don't know, 10 people or 20 people or something like that. Now you're 100 plus, something like that?
We're about, I think we're 69 people.
Okay, so still lots of growth,
it's a ton of growth.
Like
we started the company started as like 5 guys.
Right. So what does that mean for your day-to-day, right? Like you said, you were answering emails, you were doing all this other stuff, and now hopefully you're able to just work on the Rift?
It depends on the day. I mean, here at CES, it's wake up early and then slave all day.
Sure.
But
talk to me.
Yeah.
Et cetera, et cetera.
But the oasis in the desert, this Engadget stage.
Sure.
But it's a mix of things. I spend a lot of time talking to game developers that we're working with, and also working with hardware and component manufacturers, working on the next generation Rift stuff.
Sure.
We have a big prototyping team, and we're always building new hardware, and I do a lot of work in that area.
Sure.
And then I do the typical stuff, like occasionally I have to talk to media or talk to people who just want to talk.
Sure. I mean, of course, you tend to have pretty interesting things to say, so that's a good reason. So it's been interesting. I guess let me back up a little bit. Let's go back to the life story instead of.
Sure.
I keep getting off on tangents because there's all these. I feel like there's so much to talk about with regard to this stuff. There's so much interest around all these different things, and it's really easy to jump into these other things. So let's back up to where you came from, and you said you were a tinkerer, and you presumably were also into games.
Yes. I mean, you have to be into games.
Yeah.
I played some games growing up, but I wasn't even all that much into gaming. I did a lot of reading. I did a lot of hardware projects, especially solid-state laser systems.
Solid-state laser systems?
Well, I didn't really start building gas lasers until I was a lot older. But
okay. You should get that on a shirt.
I have a cool laser shirt. This is a tangent, but I have a sign from the 60s that it's a military lab testing sign that I got through a government auction, and it says, "Danger: high laser energy high laser energy emissions in progress." And I really like that sign.
I'll bet. So yeah, you were making gas lasers?
Or not diode, all diode based, but gas lasers are way more tricky. But anyways, the point is, I was just working on a lot of cool electronics and hardware projects.
Sure.
But I did play games. And when I got into my teens and started making money, I started dumping a ton of money into PC gaming, especially. Just always making sure that I had the best rig, the best hardware, trying to push the experience as far as I could, because I'd always been kind of fascinated with the idea of virtual reality.
Sure.
And so before 3D was cool, before Avatar brought it back, I had a triple 3D monitor set up, and I was like, trying to get to that point. I was like, I got to make it so it's like you're in the game, and. I started collecting head-mounted displays, started collecting VR hardware from the past, government auctions, hospital liquidation sales, all kinds of fun things, and trying to figure out if I could modify any of those to be the kind of experience I wanted. And I ended up basically doing everything from scratch all over again when I was designing the Rift.
That just seems it seems like such a huge jump from that world to where we are now. And it's only been 10 years?
I think it was almost inevitable. I mean, the reason that this didn't happen, and the reason that I was able to pull it off, it wasn't because I had some people imagine that I operate on a higher plane of existence or some ridiculous thing. It's like, no, here's what actually happened. VR as a consumer industry basically died. It's been dead for well over a decade. It went on in the pro market, but it was never a consumer thing.
Sure.
And people had really, nobody thought good things about consumer VR. You know, they say, Virtual Boy, I've tried that, that's lame.
Sure.
And I think that, you know, a whole generation has passed, and technology in the background continued to advance and advance and advance. And then all of a sudden, all the pieces were there. It was finally possible to make a good VR experience in a consumer device that didn't cost too much. And if people had been paying attention to VR like they had in the 80s and 90s, I think that there would have been a lot more people doing it. And at the same time, I think a lot of people, I mean, we talked about it earlier, but they want VR. I don't think you can ask any gamer and say, hey, do you not want to be immersed inside your video games? I mean, maybe not every game, maybe there's some types of games that are better on other things, but in general, every gamer wants this type of thing. And so when it came along and it became clear that it was time, it was kind of inevitable that it would take off and everyone would become interested in it. I'm just kind of happy because before, this whole VR enthusiast thing was like me and a few other nerds talking on a forum and everyone thought we were crazy. And now we've sold like 50,000 dev kits, so there's like 50,000 brand new friends.
Right.